Okay, pause and copy. Beep, boop, boop, beep, boop, boop. Integration by parts. So we're going to start with the product rule and derive a nice little formula that will help us with certain integrals. So product rule, rearrange things, solve for this term. That's what I did. And I rearranged these two factors. Okay, now essentially we're going to integrate both sides. So you can imagine integral signs appearing in all three places, which gives us this formula. Okay, notice that in the middle, we are integrating a derivative, so we end up back where we started. Okay, there'll be a plus c eventually, but more or less back where we started. Now, this is one form of the formula we want, but it's not the one that I'm going to use. So I'm going to keep going. I'm going to do a couple things. So pause and copy. First thing is I write it out more formally. Up here I'm being kind of informal, just because it's easier to write it. But now that I have the formal equation, I'll make a couple replacements. Okay, u is going to be f, v is going to be g of x. So we're doing a kind of a change of variables here. Now, this is what's called a differential. I mean, maybe you want to think of it as, well, dv dx is going to be g prime of x, and then solve for dv to get that equation. Yeah, differentials are a bit strange, but they are useful in deriving these formulas. So we take these things in red, we're going to plug them back in to this equation, and we're going to get our integration by parts formula in the rectangle. So g prime dx became just dv, f prime dx became just du, and the rest I think is straightforward. So in the rectangle is what we'll use, called IBP, or integration by parts formula. So let's do an example. The classic first example in integration by parts. I'll first point out that there is no inside function. Okay, so substitution, I can't see how that's going to help here. But integration by parts allows us to proceed here. So what do I need to do in order to use this formula here? Well, this guy here is my original integral. Okay, so, and what I'm going to do is replace my original integral with all this stuff here. And hopefully, this new integral that arises will be better than the original. And that's basically it. A lot of details to go through, but here we go. So the first thing we're going to do is choose u and choose dv so that u dv equals this thing here. So I need to choose u and choose dv so that when I do the product, I get x e to the x dx. Okay, so my choices are u is equal to x, and dv is equal to the rest of it. Okay, notice that I do indeed get this. And that is extremely important to check. Okay, anytime you make a choice of u and dv, you're going to need to double check that u times dv actually equals this bit here. Okay, for the rest of the formula, oopsie daisy. I've got u and dv down here, but I'm going to need just v, right? I'm also going to need du. Okay, so to find du, you could start with u is equal to x, do a derivative of both sides, and then see that du is equal to dx. And to find v, essentially what I'm going to do is say put an integral here, and resolve both sides. Okay, so this is what I get. When you do the integral of e to the x, you get just e to the x. When you do the integral of, well, just the number 1 here, you can think of it, you get just the variable in question, which is v. So that's what I get. Now I'm ready to take my 4 things here and plug them into my by-parts equation. So here's my by-parts equation written again, or just the right-hand side. So I've just taken this part here, copied it down. Okay, then I'll plug in the things that I've found in my red rectangle here. And look what happened. The new integral is indeed much better than the original integral. The original integral I, was confused about, but this one down here is the simplest of all. It's just e to the x, and that's it. So you can double check that the derivative of this does indeed equal x e to the x. But for now, I'll just review what we did quickly. You got to make some choices. You have to choose u, and you have to choose dv. Okay, then you have to do some work to find du and to find v. Okay, to find du, you were doing a derivative, essentially. And to find v, you're doing a integration. Okay, remember, you're doing this integration here, essentially. You may say, oh, well, maybe there should be a plus c here. Well, we're going to leave that out and wait until the end to place our plus c. Okay. Another example. X sine x. Okay, once again, I choose u is equal to something, dv is equal to the rest. And I double check that u times dv does indeed equal what's in my red oval here. Okay, I do a derivative to find this thing here. I do an antiderivative to find v. And then I use my formula to plug everything back in. So this is uv minus integral v du. So I take a step to, no, I don't take a step. You may want to take a step in here to simplify the double negative here. I don't do that. I just notice that this integral is going to be nice and simple, which was the whole point of integration by parts.